Hello everyone and welcome to the part 6 video notes of unit 6. This is the last section for video notes for this unit. Awesome, you've made it all the way through one unit so far this trimester. Great work. This is the second video revolving around target 17, and so this is going to deal with trig ratios again, so sine, cosine, tangent. Remember, we've been working with SOH, CA, TOA. Because when we say trig ratios, trig means sine, cosine, tangent. That's the S, C, and T. But then ratios means make a fraction. And remember, depending on which trig function we use, we make a different fraction. And the fractions are the O, H's, and A's. So sine is opposite over hypotenuse. Cosine adjacent over hypotenuse. Tangent is opposite over adjacent. And so this idea of SOH-CA-TOA helps us remember which trig function should we use, and when we use it, what does the fraction that we set up look like, right? Now, we're going to do some different things today. Last time, we used trig functions based around an angle to find a side. Today, we're going to use trig functions still based around an angle, but we're going to figure out what that angle is based on what the sides are. And so that involves doing the opposite of what we did yesterday. Just like in algebra, right? If you have like 5x and it equals some number, you have to, that's 5 times x. To get x by itself, you have to do the opposite. So we divide both sides by 5. I hope you can picture that analogy. That's essentially, again, what we are going to be doing today. But the difference is instead of dividing or multiplying or adding or subtracting, we have to do the opposite of a trig function. And the opposite of a trig function is an inverse trig function. And so it's relatively simple once you get the hang of it, but let's really work here on, focusing, understanding, and getting the hang of this. So it says find the acute angles in the right triangle. That's going to mean R and T. Remember, it doesn't mean S. We already know S. It's a 90, but we just don't base anything with sine, cosine, or tangent around 90-degree angles. So what I want to do is let's find T first. Let's find T first. And so I'm going to talk about angle T. And if we base everything off of angle T, right, sine, cosine, tangent, what we want to do is identify opposite, which is across the triangle, which is 8, hypotenuse, which is across from our 90, no good in this example because there's no information there, and then the connected side is our adjacent side. So if we want to work with angle T using sine, cosine, or tangent, we have to work with opposite and adjacent because we know 8 and 11. And so let's just generally set this up, right? Opposite and adjacent is our TOA. So that means we're using tangent. So tangent. Now, we don't know what angle T is. And so we can't put a number in this parentheses. So for now, we're just going to put angle T itself. So we're just going to do the tangent of angle T. Remember, tangent always equals opposite over adjacent. So 8 over 11. Now, notice there's no x, no y, no variable in our fraction, right? It's 8 divided by 11. That's a thing. The variable is t. What we're wondering about is what is angle t? So we have to do the opposite of an entire trig function, right? We have to do the opposite of what tangent is. And so what the opposite of tangent is called the inverse tangent. And so we'll be able to get what angle T is, we'll know what it equals, and we'll call it the measure of angle T, if we do the opposite of the tangent to this fraction. And so again, the opposite of the tangent is called the tangent inverse, and we write it tan, but this time we put a -1, that means inverse, and we're about to go to our calculator, it's going to put parentheses there, and what we type in the parentheses is 8 divided by 11. So if we type this inverse tangent of our fraction, it'll tell us what our angle equals. And so let's do that real quick. Now, I need you to bear with me because I have a different kind of calculator than you, but here's the idea. Again, just to remind you, what we need to put in our calculator is tangent -1, and then in our parentheses, 8 divided by 11. And so when we go to our calculator, we want to see that symbol, tangent -1. On your calculators, chances are you are going to hit the second button, and then you're going to look for sine, cosine, tangent again, but above those keys, in probably blue, you'll see those same words, sine, cos, tan, but you'll see a -1 around them. If I click this inverse button, you'll see what I'm saying. Sine -1, cosine -1, tangent -1. That's what we need to use here. On your calculators, chances are you have to hit the second button first, then the sine, cosine, tangent buttons. So again, to remind you, what we want to type in is tan -1, and then 8 divided by 11 in the parentheses. So let's come back here. We'll hit the tan -1. Notice it says arctan on my screen. It means the same thing as tan -1, so don't get thrown off by that. And then we'll type 8 divided by 11, and we'll close the parentheses. Always remember to be in degree mode, and this is going to tell us about 36.0 degrees. So angle T is 36.0 degrees, and that's our answer. And so that's how we use side lengths to find angles. Let's keep doing this. Let's keep practicing this. So let's find angle R now. Now, remember, to find angle R, now everything's based off of angle R. So let's get rid of these arrows and stuff because we need to refigure out what's opposite, adjacent, and hypotenuse. And so here we go. From angle R, now 11 is opposite. Remember, hypotenuse doesn't matter. There's no info there. And so then that makes 8 adjacent. And so for us to find angle R, we have to work with opposite and adjacent. That's tangent again. Remember, we are looking for our angle. We don't know it. So I'm just going to put R in parentheses. And then I'm going to make my fraction. Opposite divided by adjacent. So this time it's 11 divided by 8. So it's the reverse of what we just did in purple. And so if we want to find angle R now, remember measure of angle R, we're going to do this tan -1 thing. But then we're going to have 11 divided by 8. So tan -1 of 11 divided by 8. And so that's what we want to type into our calculator. So I'm going to go back to the other screen. And I'm going to clear this. And I'm going to hit inverse. You got to hit second. And then tan -1. And then this time 11 divided by 8. Close your parenthesis. Hit equal. And it's telling us that that's a 53.9 degree angle. We'll round up to 54.0. 54.0. Now, real quick, before we start speeding this thing up, I want to put some of those numbers in the triangle and show you something cool. Right? Angle R is 54 degrees. I'm going to put 54. And angle T we found to be 36 degrees. So I'm going to put 36 here. And we know this one's 90. And we also know that all three angles in a triangle should always add up to 180 degrees. So I'm going to go to the calculator and do 36 plus 54 plus 90. Any guess at what I will get? Let's see. 36. Oops, that's a minus. Clear. 36 plus 54 plus 90. Enter. 180, as we should. So just further proof to you that these sine, cosine, tangent things, you know, they make sense and they work with the triangle in the ways that we know the triangle works. It just knows that there's supposed to be a specific ratio based on whatever degree measures we're working with. And so we can work forwards and backwards. Yesterday we used a degree measure and we found a side. Today we're using two sides and it helps us find a degree measure. So let's whip through that again real quick. I know this video takes a lot of explaining right now. Let's find T and C. So I'm going to start with T over here. So we want angle T. And so we're going to look at what we have. We have hypotenuse, right? And then 8 is the adjacent side. So we have to work with adjacent and hypotenuse. That's the cosine. So the cosine of angle T, right? And it equals adjacent divided by hypotenuse. So 8 divided by 12. Now, remember we want angle T, so we will get angle T by doing the cosine -1 of our fraction. So we want to type into our calculator cosine -1, 8 divided by 12. And so when we do that, cosine -1 of 8 divided by 12, here we go, let's figure it out. I'll hit inverse, you'll hit second. This time I'm picking cosine -1, 8 divided by 12. Close it, equals 48.2. 48.2 when we round. And we will call that 48.2 degrees. All right, perfect. So now let's find angle C. Do that in a different color here. So we're looking at angle C. So I'm going to clear up the triangle because, as you know by now, things change, except for our hypotenuse. Hypotenuse is always across from the 90. It always stays the same. But now our 8 is opposite of angle C. So we need to work with opposite and hypotenuse. Opposite and hypotenuse. And so let's do that. We want angle C. It's going to, not equal yet. To find angle C, we need to use opposite and hypotenuse. That's so that's the sine, and the sine, I'm sorry, that is not spelled very well. And the sine, right, and we're working with angle C. Oh my goodness, I'm sorry. This is really feeling like real class right now. Let's start over. So we're trying to find angle C. 8 is opposite of angle C. 12 is our hypotenuse. So we have to use sine, because sine is so, which is opposite over hypotenuse. And we'll do the sine of angle C is going to equal opposite divided by hypotenuse. So 8 divided by 12. So then we will figure out what angle C is if we do the sine -1, or the sine inverse of 8 divided by 12, right? We always just do the sine or cosine or tangent inverse of whatever fraction we set up. And so we just need to type that into our calculator, and we get sine -1 of 8 divided by 12. And that equals 41.8. 41.8 degrees. And so there's our second one, right? And now I want to add that to our triangle. We know C is 41.8. We know T is 48.2. And once again, I just want to show you, this one's 90. If we add those together, it'll equal 180 degrees. So 41.8 plus, hit minus again, plus 48.2 plus 90, and that equals 180, as it should. Okay, now I know we've only done 2 things, and we've filled up an entire video. So we will go a little bit quicker from here on out, but that is the basic idea here, and that's, linking it back to yesterday, that is the opposite of what we're doing yesterday. Now we're doing the inverse function, the -1, and it'll help us find angles. The regular function, like yesterday, helped us find sine. All right, I'll see you in just a second, and we will finish up this part of the note packet.